Hey everyone! Today we are cracking open the actual blueprint of our planet's climate. We're going to see how everything, from a single sunny day to a massive, crazy blizzard, fits into a much bigger and honestly, a much more fascinating story.
You've all heard it, right? A record-breaking snowstorm hits, and somebody, somewhere, says, "So much for global warming." But is a single blizzard really the whole story? Not even close. And the answer lies in a super important distinction, one that's really at the heart of understanding our planet.
So here's our game plan for today. We're going to start with that big difference between weather and climate. Then we'll look at the recipe that makes climate, explore the global controls that shape it, zoom in to see how something like rain is made, and finally tie it all together to see why it shapes the world we live in.
All right, let's jump right in and tackle the most important distinction first, the difference between weather and climate. I promise, if you get this one thing, it's the key that unlocks pretty much everything else we're going to talk about.
Okay, think of it this way. Weather is the daily headline. It's what's happening right now, in your town this week. It's your mood. Climate, on the other hand, that's the entire history book. It's the long-term story, your whole personality. It's the average of all those daily headlines over decades. See? That's why one blizzard, one single headline, can never tell you the whole story.
Okay, so what is climate actually made of? Well, just like any good recipe, it has core ingredients. Scientists call them elements. And these are the basic things that we can actually measure to describe what's going on out there in the atmosphere. And here they are, the 7 core ingredients in our climate recipe. You've got the obvious ones, right? Like temperature and sunshine, but then you have these other crucial forces like air pressure and humidity. The important thing is, none of these exist on their own. They're all constantly interacting in this incredibly complex dance that creates the climate we all experience.
So let's start with the main engine, temperature. It's way more than just how hot or cold it feels. It is the primary driver of the entire system. You know, heat energy is what dictates how much water evaporates into the air, and it's what gets the atmosphere moving, which sets the stage for basically everything else.
Next up, we have pressure. This is literally the weight of the air pushing down on us. And it follows this one really simple but incredibly powerful rule you see here. Air always wants to move from high pressure to low pressure. And that constant rush to find balance, that's what we feel every single day as wind.
So if those 7 elements are the ingredients in our recipe, what decides the final dish? You know, why is a desert so different from a rainforest? Well, that's where factors come in. You can think of these as the control dials on the oven shaping the climate of all the different parts of the world.
Okay, here's a great little puzzle that perfectly explains one of the most important climate controls. You climb a mountain, right? You're technically getting closer to the sun, and yet it gets colder. Why is that? The answer is a super powerful factor called altitude.
And here's the rule of thumb for it. For every 1,000 meters you go up, the temperature drops about 6.5 degrees Celsius. It's called the normal lapse rate. And it happens because our atmosphere is heated from the ground up, kind of like a pan on a stove. So the further you get from that warm surface, the colder it gets, because the air is just thinner and can't hold on to the heat.
So let's put that lapse rate to the test with a real-world example. Imagine we're at the base of a 4,000-meter mountain, and it's a nice, warm 29 degrees Celsius. Using what we just learned, what would you guess the temperature is going to be way up at the summit?
The answer? A chilly 3 degrees Celsius. That is a massive 26-degree drop. This one factor, altitude, is so powerful, it's the reason you can find snow-capped mountains sitting right on the equator. It's wild.
Now, the other huge control dial is latitude, basically how far you are from the equator. Near the equator, the sun's rays hit the Earth almost straight on, like a focused spotlight, concentrating all that energy. But as you move towards the poles, the curve of the Earth means those same rays hit at an angle, spreading that energy out over a much larger area. That makes it weaker and a whole lot colder.
Okay, so now that we have the ingredients and the control dials, let's see them in action. We're going to take one of our elements, rainfall, and look at the fascinating process of how it's actually made. This is really where all these concepts start to come together.
So this is a classic process, especially in the tropics. The intense sun just bakes the ground. That, in turn, heats the moist air right above it, forcing it to rise. As that air shoots upwards, it cools down. Remember that lapse rate? And the moisture condenses into these massive, towering cumulonimbus clouds. Eventually, the water droplets get too heavy, and boom, you get a classic tropical downpour, often with a full-on lightning show.
But that's not the only way to make rain.
The key difference here is the trigger. With convectional rain, it's just pure heat forcing the air up. With orographic rain, which you see on the left, it's a physical barrier. Moist air comes along, hits a mountain, and is forced to climb. As it rises, it cools, and it has to dump all its rain on what's called the windward side, the side that's facing the wind.
So we've covered weather versus climate, the ingredients, and the controls. But this isn't just some abstract science lesson. Why does any of this actually matter? Well, because these fundamental principles are basically the invisible architects of our entire world.
I mean, think about it. The local climate dictates everything. It determines the kind of houses we need to build to stay comfortable, the clothes we have to wear to survive, even the jobs that are available, like farming specific crops that can only grow in certain conditions. It shapes the very plants around us, and it influences where we build our greatest cities. Our whole world is built on a climatic blueprint.
And really, that brings us right back to where we started. If there's just one thing you take away from all this, let it be this idea right here. Weather is just a single page, a fleeting moment. Climate is the epic, multi-generational story of our world.
So we've seen the ingredients, and we've seen the control dials, like latitude and altitude, that govern our planet. The final, and really the most critical question is this. Now that we understand the rules of the system, what happens when